Can you kind of go over the, I don't even know how to say it, renin and
Angiotensin, aldosterone.
Yep, that.
That one. I can. That's gonna be a good one to know. The name's so long I can't even fit it on the paper. Okay, renin, angiotensin, aldosterone mechanism. So, how does it start? Hopefully my markers work.
Isn't it activated by low blood pressure?
Right, so the kidneys, that's a really fat kidney.
Well, it's actually pretty good. Looks legit, right?
So the kidney
Senses.
senses what?
Low.
Low blood pressure. And when it senses low blood pressure, it secretes
Renin.
renin. Okay? So what does renin do?
It converts angiotensin to angiotensin 1, right?
Yeah, so we have the liver over here now. Sort of. Liver, kind of. And the liver, I drew that too big, but the liver is always making angiotensinogen. So renin converts angiotensinogen into angiotensin 1. Screen's not working very good for me. Not a whole lot there. Okay. Okay, so we have angiotensin 1. Then what happens?
In the liver, there's the angiotensin converting enzyme.
Close, in the lungs.
Oh, in the lungs, sorry, that's what I meant.
What
Yep.
is it, ACE or something?
The ACE enzyme, angiotensin converting enzyme. So now we have our lungs. Very narrow lungs.
There's a picture of this, right?
Yes, there is. I'm basically just redrawing the picture in the book. Okay, and in the lungs is that ACE enzyme. So angiotensin 1 goes to the blood, through the lungs. ACE enzyme converts it into angiotensin 2. Okay. Then what does angiotensin 2 do?
It causes vasoconstriction in the blood vessels.
Good. So here's my beautiful representation of blood vessels. Angiotensin 2 acts on the blood vessels, we get the vasoconstriction. I took a dive. Anyway, we get vasoconstriction, right? What else does it do?
It goes to the medulla and causes the release of aldosterone.
The cortex, we're
Oh.
close. So we have the adrenal cortex up here. Alright, so inner parts of the medulla. Aldosterone gets released from the cortex. So, angiotensin 2 acts on the cortex, and the cortex releases aldosterone. And where does the aldosterone go? What does it signal?
Um,
Reabsorption of
Yeah.
water?
It tells the liver to take up more sodium, doesn't it?
Tells the kidneys.
Kidneys, I can't get the organs right.
Okay, so this is our aldosterone. Tells the kidneys to increase sodium reabsorption. Why do we want increased sodium reabsorption?
More water.
Water follows salt, right?
Mm-hmm.
Water follows solute. So if we reabsorb more sodium back into our blood, we're going to reabsorb more water back into our blood too. And so we've probably gone over this before, but aldosterone is lipid soluble or water soluble.
Lipid soluble.
So how do we cause increased sodium reabsorption if aldosterone is a lipid soluble hormone? How do lipid soluble hormones work?
They create new proteins.
Create new proteins. So what new protein are we going to make? This is a little bit beyond what you need to worry about for this chapter, but we're going to get to the kidneys and then you're going to talk about it again, so we might as well just hit it now.
It's the morning.
If we want to transport sodium, what kind of protein do we need to make?
I feel like I'm overthinking this.
You probably are. It's a lot more simple than you're thinking. How about a sodium transport protein?
Oh.
Okay.
Right? So aldosterone just tells the kidney cells to make more sodium transport proteins to transport more sodium. Put more sodium back into the blood.
Okay.
And the water follows it. So that we decrease the size of the container, plus we put more water in the container, so we use two different ways to increase our pressure. Make sense?
Yes.
What do the pre capillary sphincters do?
Anybody know?
I remember him telling a story about a fishtail and like how he saw the blood like stop and then it would go again. I think that had to do
Oh,
with
I haven't
this.
heard that one. That's the first in a long time I haven't heard one of the stories that Brother is in class.
And
Is it
then
so that the blood doesn't flow back, or is that, I don't know what the pre-sphincter is.
So there's,
Yes.
I see your book. I don't know how well.
This deals with blood flow and all that stuff.
It does do the blood flow. So, the other book was being used. I think there's a good picture here. I know there's some good ones in the slides, some better ones, but. Kind of. Not really.
does it have to do with this?
Yes. So you see these sphincters. I'm just gonna make this big. Maybe. I'm Mac challenged, Apple challenged.
Do you need me to do it?
Sure. Oh, just put play? Sweet. Okay, so you have these sphincters, the pre-capillary sphincters. So the blood is flowing in this direction, but it's going to also flow this direction, right? Top to bottom. So you have these sphincters that can control that blood flow. So let's say this tissue, let's say it was like this morning, I biked here, right? So this morning, the muscles in my legs were needing a little bit of extra oxygen. So all those capillaries were open. Well, then I got here and, rested up, whatever. So for a time, those particular muscles didn't need as much oxygen, they were full. Basically, this is the way of our body saying what needs oxygen the most, and this is how I'm going to direct that oxygen where it actually needs to go. So if that particular part of the body doesn't need oxygen, we're just going to close off these sphincters and bypass it. A little bit of blood is going to flow through, like this one channel, it'll flow through, but all this extra capillaries, they're just going to be closed off because we don't need them right now. Once that tissue starts to starve, a little, maybe not starve, but once it gets hungry for oxygen, it'll open back up again. And the way that actually works, and so here's the next picture here. So they're open right now, it'll close off and blood will just pass right through because that tissue doesn't need the oxygen, it's good. So the way that works is those sphincters, their muscles too, they need oxygen too. As long as they have oxygen, they're going to clamp down. Which you can assume if they have oxygen, then probably the other tissues around them have oxygen too. Once they get rid of oxygen, or once they're used up all their oxygen, they run out of energy, right? Oxygen, we use oxygen to make energy. Once they don't have that energy anymore, they relax and open up. And we get more blood flow, the tissues and sphincters get oxygen again, and they'll close off.
Okay.
Good, thank you.